This is Cambridge IGCSE Chemistry Paper 2 Multiple Choice Extended for May-June 2020. Variant 2. Question number 1. A mixture of ice and water is left to stand and the ice melts. Which row describes what happens as the ice is melting? The keyword here is melting, which means that it's at a melting point. At a melting point, the temperature of the mixture actually remains the same. And the reason why it remains the same is because energy is used to overcome the attractive forces between the particles, right? Or within the particles. But in the context of water, there will be the molecular forces that is found between water molecules. Okay. The justification for C is more suitable for heating process, but it's not suitable for melting point or boiling point explanations. Question number 2. Which piece of apparatus is used to measure 25.0 cubic centimeters of aqueous sodium hydroxide? The keyword here is 25.0 cubic centimeters. If you want to measure such an accurate measurement, the best way is to use a volumetric pipette, right? A volumetric pipette has the best accuracy out of the other measuring apparatus found in labs of most schools. Whereas for this specific volume, most pipettes are designed to measure this particular volume, right? So question number 3, paper chromatography is used to determine the RF values of 4 different food colorings. Which food coloring has an RF value of 0.6? So essentially it's trying to tell you that it's 60% of the paper, right? 60% of the distance traveled by the solvent from the baseline, right? So just by looking at it, actually it's C, right? It's C that will be 60% of the chromatography paper in terms of from the baseline to the solvent front. However, let's just double check. All right, 0.6. The formula for RF is the distance that solute traveled from the baseline over the distance traveled by the solvent from the baseline. All right, so let me just put a short form D as of distance. So all you need to do is just check from here. It's 25 and 15. So 15 over 25, which is 3 out of 5, which is 0.6. Right? So the answer is indeed C. Moving on to question number 4. The diagram shows the electronic structure of a particle with a nucleon number, mass number of 40. The table shows the suggestion that 3 students, 1, 2, and 3, made to identify the particle. Which students are correct? Now, let's just try to understand the question first. Based on observation, I'm seeing 2, 8, 8 as the electronic structure. So that means that in total, there's 18 electrons, right? And the mass is 40. So just look at the periodic table real quick. Give me a moment. I'm trying to find the periodic table. So the mass 40 are suitable for argon and calcium. Argon and calcium. All right, this has mass 40. Chlorine actually has 35.5. If I'm not, yeah, it is 35.5. Right? So indeed, calcium ion, right, loses 2 electrons. It has 20 protons. Okay, and then having a +2 charge, that means that it has 18 electrons. Argon, it has 18 protons, and because it's a neutral atom, so it also has 18 electrons. So the best answer out of this question is B. Right, moving on to the next question, 5. The electronic structures of 2 atoms, P and Q, are shown. P and Q combine together to form a compound. What is the type of bonding in the compound and what is the formula of the compound? So if you just refer to the periodic table, this should be fluorine and this should be lithium. So lithium is a metal and fluorine is a Non-metal. So when the metal and non-metal atom come together, they will form ionic bonding, right? Of course, there's like transfer of electrons involved, formation of ions involved, and then followed by ionic bonding formation. So the best answer is actually A. All right, group 1 and group 7, they form a compound with a 1-to-1 ratio, so PQ. Right? So, this one. Which statement about the structure of the metal explains why metals are malleable? The keyword here is malleable. Malleable means that you can actually force the metal into different shapes. The reason why is that such, just like my wire contains copper. Why is that such? Is because the layers of metal ions can slide over each other. Right? The answer is B. Moving on to 7. The bonding structure and melting point of sodium chloride and sulfur dichloride is shown. Why does sulfur dichloride have a lower melting point than sodium chloride? All right, so sulfur dichloride is actually composed of 2 nonmetals, and sodium chloride is composed of 1 metal and non-metal. So, which pretty much tells you that it's an ionic compound and a covalent compound, respectively, for both compounds. So, the reason why it has a lower melting point is because the bonding is easier to be broken, right? In sulfur dichloride than sodium chloride. The attractive forces are easier to be broken. So the answer, although most people would think that it's B, the answer is not B. It's actually C. All right, covalent bonds are actually very strong. Many students thought that it's actually weak. No, that's not the case. Right? Actually, the weak forces that is found in molecules is actually between the molecules, not within the molecule. Right? So just imagine this is sulfur dichloride. All right, it's actually between the molecules. This is the weak force that is found between molecules. All right, so a misconception is B. Let me just check the answer real quick for this one. Oops, okay, the answer is D. My bad, I didn't look at the second part. Okay, sodium chloride is an ionic compound. You shouldn't associate it with the word molecules at all. All right, molecules are covalent compounds. My bad for that. Should have read everything. So make sure to check your answers. All right, let's just double check one last time. The attractive forces between molecules in sulfur dichloride are weaker than the ionic bonds in sodium chloride. In ionic compounds, we are trying to break the ionic bond. All right, the answer is D. Moving on to question number 8. Lead-2 nitrate reacts with potassium iodide to form a yellow precipitate and a soluble salt. What is the equation for the reaction? All right, seems like it wants us to use the correct numbers. Actually, you don't need to know everything. You just need to check whether each element has the correct number. So from what I can see, I already found that in C, this is wrong. All right, you have 2 lead on the left, but then you only have 1 lead on the right. So C is definitely wrong. Let's just see. Seems like we can't do that for other questions. No, there is one more that we can eliminate. I and I for A, right? There's only 1 I on A on the left-hand side, and there's 2 I's. All right, there are 2 I's on the right-hand side of A. So we can't take A as an answer as well. So it's either B or D. So we just need to check the numbers. It seems like the answer is D. Right? If you look at B, nitrate is not having the same amount on both sides. Right? The answer is D. Right, let me just check the answers for other questions for a moment. Just real quick, because just now I said it's D. I have my mark scheme here. It's just that I just want to make sure that I'm not teaching anything wrong. D, C, yep. And then this is B, this is E, this is B, this is D and B. Pretty much we got everything correct. Right? When you do your own revisions, it's useful to have a mark scheme beside you. Try to do it without mark scheme first, and then followed by referring to the mark scheme. Right? So let's look at number 9. The Haber process is a reversible reaction. The reaction has a 30% yield of ammonia. Which volume of ammonia gas measured at room temperature and pressure is obtained by reacting 0.75 moles of hydrogen with excess nitrogen? Now, we see what's the point of the experiment, what's the point of the production. It's focusing only in ammonia and hydrogen. Nitrogen is in excess. It's not the limiting factor. So you can just forget about it for now and focus only in ammonia and hydrogen. Tunnel vision these two parts and see that based on the chemical equation, the recipe itself, it tells you that in theory, right, the theoretical mole ratio is a 3:2 ratio, right, for hydrogen gas and ammonia, right, based on the coefficients, 3:2 ratio. Right, and then we just need to find out if we use, in experiments, we use 0.75, how much will it get in theory? All right, that should be 0.5. Let me show you how I do it. Essentially, what I do is basically trying to, okay, there's a way, which is you just try to convert to 1 unit first. All right, so this will be 2/3. You divide 3 from both sides, and then you just follow that by multiply by 0.75 for both sides. All right, you find the unit value first, and then find the for 0.75. Right, so you get this theoretical mole ratio. Then look at the question. It says that, oh, although in theory you should get 0.5, but then in real life that's not ideal. You get 30% yield instead. So with that, right, so you just try to find, okay, 0.5, right, I'm only getting 30% out of it, which is 30 out of 100. Take that and then try to find the answer. That should be 0.15. Right, so this is what you get from your own experiment, and use this to measure volume. So it's a gas, so we just multiply by molar volume, which is 24, and that will be, let me use calculator, 0.15 multiplied by 24, that should be 3.6 cubic decimeters, which is equivalent to 3,600 cubic centimeters. The answer is A. All right, now let's look at question number 10. Electrolytes can be broken down by electrolysis. Which rows are correct for each electrolyte? Seems like a lot of information, but let's just brief out and try to figure out one by one. Now, our concept here is cathode, you should expect to see generally cation ions getting discharged. Right? Just remember cathode, cation ions getting discharged in electrolysis. So you can pretty much forget about 3. Right? You see that there's an anion here. So that's most likely not the answer. Right? Now, next part is knowing your anode. Right? Your anode is all about anions getting discharged. I don't think we can do anything about it. So never mind. But okay, what's the next thing that you need to know is about how hydrogen ions are easily discharged compared to most metals in aqueous solutions. right? The priority for cathode is hydrogen ions over most metals, except for non-reactive metals, for example, copper. All right, think of it as a priority list. Copper will get discharged if copper is present. If it's not, it's hydrogen. Right? So what I'm seeing here is that 4 is not possible. Sodium is a very reactive metal, so it's not easily discharged. Like the ion form is not easily discharged in an electrolysis of aqueous solutions. The only way to get sodium is to melt it, melt the sodium chloride. So I think we can pretty much deduce that the answer is A, but let's just double check just to be safe. So sodium chloride, it is true, we're going to get hydrogen and oxygen because it's a dilute solution. Now, in the anode, the concept is the priority is oxygen getting discharged, right? It's actually hydroxide getting discharged, it forms oxygen, except if you're doing concentrated solutions of halides, right? This is a halide solution, it's concentrated, you're going to get halogens, right? You're going to get halogens. Okay, so the answer is A. Right, moving to 11. The electrolysis of aqueous copper 2 sulfate using inert electrodes is shown. Which statement about a reaction at an electrode is correct? Use our concept. When copper ions are present in aqueous solutions, you should expect to see copper. And the priority list for anions at the anode, in terms of discharge, there will be oxygen. Right? Sulfate will not get discharged, it will be oxygen. And there's no halides present that is concentrated. There are also no active electrodes present, so it should be oxygen. All right, so you will get copper at the cathode, negative electrode. So let's just double check the answers real quick. Hydrogen ions impossible because copper is present. So it's either A or B. Let's just double check. That will be A. Right, these are our concepts regarding electrolysis. Moving on to question number 12. Methane burns in excess oxygen. The equation is shown. Bond energies are shown. What is the energy tree for the reaction? Now, you need to know the structure in order to be able to do this. So this methane structure, 4 bonds, 4 CH bonds. Oxygen, there's 2 of them. So 2 double bonds. Carbon dioxide is, it looks like this. It has 2 carbon-oxygen bonds. And then for water, those are single covalent bonds, and then there's 2 of them. All right, so the reactants, you need to break the bonds, which is an investment. For this part is it releases energy. So this is the profit, revenue, should I say. Right? So let's just see. So this one will be 410 multiplied by 4. This one will be 496 multiplied by 2. The release part, it will be 805 times 2. And these 2 water molecules, it will be 460 times 4. So on first glance, it seems like the answer is A, which should be true. Should be true. Right? It's the bond breaking energy takeaway minus the bond release, like the energy released from bond formation. Right? Yeah, question 12 is A. Now, question 13, which statements about hydrogen fuel cells are correct? So we like this because water, it's clean, water is formed as the only waste product, and the equation is this one. Hydrogen and oxygen, they react together to form water. So answer is A. All right. For 2, it will be more relevant to most fuels, like in terms of complete combustion. I would say organic fuels, complete combustion. Whereas for 4, no, it's not endothermic, it's exothermic. It releases energy to you. All right. Now, question number 14. Which list contains only chemical changes? In chemical changes, essentially the formula will change, right? The formula of the chemical will change, right? State change is a physical change, like from solid, liquid to gas or to aqueous solutions. So A is definitely wrong. B, rusting is chemical. Freezing and subliming are physical. So the answer is C, neutralization, which you form a different chemical, for example, acid-base salt, polymerization, like for example, amino acids to protein, combustion, fuel, which contains like carbon, hydrogen, for example, turns into carbon dioxide and water. That's a chemical formula change. All right, the answer is C. Moving on to question 15. The results are of adding excess marble chips calcium carbonate to hydrochloric acid at 50 degrees Celsius and 30 degrees Celsius are shown. Only the temperature is changed. Which row describes the reacting particles at 30 degrees Celsius compared to those at 50 degrees Celsius? So that's actually, well, at a higher temperature, you're providing more heat energy to the particles, so they gain kinetic energy, which means they collide more, they collide with a greater energy. So the answer is A. Right? Pretty straight. Wait, hold up. It's referring to 30 degrees Celsius compared to 50 degrees Celsius. My bad. Answer should be D. Okay? Double check your answers. Don't be like me. Right? At the lower temperature, it should be lower, lower. At the higher temperature, it should be higher, higher. Right? Look at question 16. Methane reacts with steam and an equilibrium is reached. The forward reaction is endothermic. Which row shows that how the amount of hydrogen at equilibrium changes when the pressure or temperature is changed as indicated? Okay, I see that this, it tries to confuse you, but if you just look closely, this is the control variables. Essentially, you just want to see the effect of temperature to the yield of hydrogen, or the other way around, which is based on pressure to the amount of hydrogen. You don't look at the temperature, right? So you shouldn't get distracted by three columns. Just focus on the changes, the independent variable to the dependent variable. All right, don't look at these two. Essentially, you can just pretty much forget about it, right? So focus on what happens when I decrease my temperature to the amount of hydrogen. Even by guessing, A and B should be wrong. Even just by guessing. You see, if it decrease, this one increase. If this one increase, this one decrease. Well, pretty much we know that, right? But then the effects are both of them are wrong, right? For endothermic reaction, increasing temperature will increase yield, will increase the endothermic. Sorry, let me rephrase that. It will favor the endothermic direction, right? So answer is either C or D. So pressure actually affects an equilibrium reaction based on the number of moles present in both sides in terms of gases. So on the left, I see there are two gases. On the right, there's four gases. So in order to drive forward the forward reaction, we need to decrease the pressure. Decreasing pressure, increase yield. Increase pressure, decrease yield. So it's either C or D. Let me just check that real quick. Yeah, the answer should be C. Right? The answer should be C. Okay, it's a pretty distracting question, but shouldn't be a problem if you just take a moment and try to digest the question. All right, question 17. When aqueous iron trichloride is added to potassium iodide, a chemical reaction occurs and iodine is formed. Which statements are correct? Now I'm observing an iodide to an iodine reaction. All right, so it's I minus to I2. So in order for this to happen, it must give out electrons. And in this process, iodide ions are oxidized because they're losing electrons in this reaction. The answer is B. All right, otherwise you can just look at the oxidation number. Iodide is -1, and then iodine is 0. Right, there's an increase in oxidation number, so which means that it's an oxidation reaction. Moving on to question 18. The graph shows how the pH of a solution changes as an acid is added to an alkali. Which letter represents the area of the graph where both acid and salt are present? So a mixture of acid and salt, oh, my bad. A mixture of acid and salt will lead to an acidic mixture. So there will be D, pretty straightforward, a low pH. All right. Now, question 19. Which statement describes a weak acid? A weak acid, okay, let's just digest these two terms. Acid is by definition, a proton donor. Weak refers to the acid is unable, the ability for the compound to ionize in the aqueous solution is not complete. It partially ionizes in the aqueous solution, right? The keyword here is partially ionized, right? Weak acids, they partially ionize, right? Which gives rise to, low concentration of hydrogen ions, which make it weak, right? Now, question 20. The apparatus shown is used to prepare aqueous copper 2 sulfate. What are X and Y? We're trying to form a salt here, and it's a copper salt, and it's a sulfate salt. So most likely I need sulfuric acid, and I need copper oxides, copper 2 oxide, copper 2 hydroxide, or copper 2 carbonate. Right? Although, well, it will be easier if you use oxide or hydroxide. Now, you can't use copper for acid because copper doesn't react with acid. So the answer here is actually C. Copper 2 oxide with sulfuric acid. All right, just look at the salt and then try to figure out what materials do you need. Sulfuric acid and also copper 2 either hydroxide or oxide. That's fine, right? But you can't use copper because copper metal is unreactive. It doesn't react with acid. Right, sorry, let me rephrase that better. It's less reactive than hydrogen. It can't displace hydrogen out of the acid solution. Right, now, question 21. Which process is not used in the preparation of an insoluble salt? We're doing a precipitation reaction. So your product is straight up just insoluble solid. It is not necessary for you to do crystallization. Crystallization is to crystallize soluble salts, right? From aqueous solution to actual like solid crystals, but this is already a solid crystal, solid salts. Right, question 21 is C. Move on to question 22. Which statement about group 1 and group 7 elements is correct? Let's just digest the info one by one. Group 7 elements are monoatomic non-metals. Now, this is a statement not for group 7, but group 8, noble gases. Then B, lithium is more reactive with water than cesium. That's wrong, right? It should be down the group. The reactivity increases for group 1, right? Let me just write it down. Increases down the group. Right. C, the melting point of group 1 metals increase down the group. That's also false. Actually, like for example, francium. Francium is a liquid at room temperature and pressure. So actually melting point decreases for group 1 down the group. This statement is more suitable for group 7. So the answer is D. Let's just check this answer real quick. Potassium bromide reacts with chlorine. Well, chlorine is more reactive, so it displaces bromide out of the solution, and then bromine will come out. And that pretty much leads to an orange solution. Right, the answer is D. Move on to question 23. The properties of the element titanium can be predicted from its position in the periodic table. Which row identifies the properties of titanium? So this titanium, if you refer to the periodic table, it belongs to the transition element, like box, like the whole like few groups and periods, like the whole package at the center of the periodic table are transition elements, right? So transition elements can be used as a catalyst. They are metals. They conduct electricity when solid. They have high density, actually. So wait, give me a moment. Trying to understand this better. Oh, wait, give me a moment. Yeah, this one is correct, right? Okay, let me just change this slightly. I'm using the same symbol, so I'm confusing myself. This should be true. This should be true. This is false, which is correct. And they form colored compounds, right? The answer is B. Okay, they are catalysts. They can be used as catalysts. They conduct electricity when solid. They have high density, and then they form colored compounds. The answer is B. Right, 24. Which diagram shows a mixture of noble gases? The keyword here is mixture of noble gases. So a trap here is, okay, let me just try to eliminate the answers first. B and C are definitely off because noble gases, they are monoatomic. They leave essentially alone, right? All of them are single monoatomic atoms, right? And then it's either A or D. So it's a mixture, so it should be A, right? A mixture composed of two or more chemicals physically mixed together. Right, now question 25. Which property is shown by all metals? The best answer should be B. All right, identify one by one. A, they can be extracted from their ores by heating with carbon only for those which is easily, well, reduced. All right, only those which are, I would say, less reactive. Okay, less reactive than carbon, then they are able to get removed from their ores. All right, otherwise it will not be possible. Then for B, they conduct electricity because they have delocalized electrons in their metallic structure. That's true for all metals. Then for C, they form acidic oxides. That's wrong. That should be for non-metal oxides. This should be a basic oxide. Actually not all metals, but most metal oxides are basic. Right? So the answer should be, answer is B. Then we look at D. So just now we just explored that copper is an exception, or the other non-reactive metals like gold, right? So they can't react with hydrochloric acid, right? So the answer is B. Moving on to question 26. Many metal carbonates decompose when they are heated. Which row describes what happens when potassium carbonate, calcium carbonate, and copper 2 carbonate are heated using a Bunsen burner? Now, just by looking at the reactivity series, remember, potassium is on top, calcium, and then copper. Right? Potassium is the most reactive, so it is very difficult for it to, well, decompose or get reduced by carbon, right? Or you do electrolysis of aqueous solution, you can't get potassium. Pretty much it needs a partner, right? It's a reactive metal, it needs a partner, right? Pretty stubborn metal. So it doesn't decompose easily. And calcium is somewhere in the middle, right? It decomposes with difficulty. Whereas copper 2, wait, hold on just a minute. I read the question wrongly. Decompose easily, that will be copper, because it's not reactive. It's pretty easily decomposed, reduced by carbon or electrolysis of aqueous solution. You can get copper. All right, this is pretty, I would say, easy going. Right, easy going. So calcium is somewhere in the middle, decomposes with difficulty, whereas for potassium carbonate, it doesn't decompose under heating. Right, so the answer for 26 is B. Right, question 27. Molten iron from the blast furnace contains impurities. The process of turning the impure iron into steel involves blowing oxygen into the molten iron and adding calcium oxide. What are the reasons for blowing in oxygen and adding calcium oxides? Now, calcium oxide in the blast furnace, we know that that actually removes acidic impurities to form slag. Right? So we can eliminate answers for B and D. Right? It doesn't react with slag, it forms slag. Right? It forms slag. So the acidic impurities, for example, are sand. Right? Sand. No, not sand. To be more precise, is silicon oxide. So it's either A or C. So it should be A, as carbon is more reactive than iron, and then it reacts with the oxygen so that you can remove it. So the answer is A. All right, give me a moment. I'm trying to check this one real quick, just to double check. Just give me a moment. Yep, that's true. And for the last one, which is just now I said about, I'm pretty sure what I'm communicating here is correct. Yep, what I'm saying is correct. Carbon is more reactive than iron, so it reacts with oxygen to remove it, to remove carbon. And then this one, the acidic impurities, for example, silicon oxide, the main impurity in the in the, let's say, hematite. And then we actually remove this to form slag. Right? So let's look at question 28. 4 iron nails are added to 4 different metal sulfate solutions. In which solution does a displacement reaction occur? Iron, metal sulfate. So iron has to be stronger than, sorry, let me use a proper term, has to be more reactive than this metal so they can displace it. So the best answer is A. As we mentioned many times, copper is less reactive than iron. So it's easily displaceable by most metals. Right? Okay, question 29. Which statement about pure water is not correct? It condenses at 100 degrees Celsius. That should be still okay, because condensation is the conversion of gas to liquid. And yeah, the boiling point is at 100 degrees Celsius. So B, it freezes at 0 degrees Celsius. That's true for pure water. Is that a C or D? The answer should be, if you're talking about not correct, the answer should be C. All right, if you turn cobalt 2 chloride paper pink instead, from blue to pink, whereas for copper 2 sulfate, it turns anhydrous copper 2 sulfate from white to blue, which is correct. So the answer is C, in terms of an incorrect answer. Moving on to question 30. 3 processes in the carbon cycle are shown. Methane reacts with oxygen, producing carbon dioxide and water. Carbon dioxide and water are absorbed and used by plants to make oxygen. Oxygen is used by living things to release energy. Which processes have taken place? The first reaction is a fuel, so we're burning, it's combustion. For the second process, plants carry out photosynthesis by taking in carbon dioxide and water and make oxygen for us. And then for the last one, oxygen used by living things, cells, to release energy. That will be respiration. So the answer is A. Right? Moving on to question 31. In the Haber process, nitrogen and hydrogen are reacted to make ammonia. The forward reaction is exothermic. Which conditions produce the maximum yield of ammonia? To produce the most product, right? Most product. So we need to cool the mixture, cool the whole experiment, as it's an exothermic reaction for the forward reaction. And we need to increase the pressure, because on the product side, it has less moles of gases. So we need high pressure and low temperature. Answer is B. Right, question 32. Which process used to prevent iron from rusting involves sacrificial protection? That will be galvanizing. Right, pretty much straightforward. Alloying is a mixture of metals. Electroplating is a different thing. Painting, yeah, those are not relevant to sacrificial protection. Right, question 33. A student suggests 3 uses of calcium carbonate, limestone, manufacture of cement, manufacture of iron, treating alkaline soils. Which suggestions are correct? It should be A. Should be A, because manufacture of cement requires limestone. That's what we know. And then manufacture of iron, in terms of the blast furnace, we need to put limestone into it. And this thing is not acidic. It can't treat alkaline soils. Right, so the answer is A. Moving on to question 34. One of the reactions used in the manufacture of sulfuric acid is shown. Which catalyst is used to increase the rate of this reaction? To increase the rate of reaction, it doesn't matter whether it's a reversible or non-reversible reaction. You use a catalyst, okay, but in the context of this question, this is actually contact process, right? So we need vanadium 5 oxide, right? Vanadium 5 oxide. The answer is C. Question 35. Ethanol is made on an industrial scale by the fermentation of sugars or by the reaction of ethene with steam in the presence of suitable catalysts. What is the disadvantage of making ethanol from ethene rather than by fermentation? It's actually pretty straightforward. The answer should be B. Right? This is fuel, this is organic fuel, which is taken, essentially, if you're talking about the source, it's coming from the earth, like the, what do you call it? The crude oil. Right? So there's a limit of how much we have. So it's a non-renewable raw material. Right? So there's a disadvantage. Pretty straightforward, right? Question 36. Which statement about compounds in the same homologous series is correct? So in the same homologous series, they will have the same chemical properties, but different physical properties. We can eliminate B and C as answers first, but look at this justification. Same number of carbon atoms does not make the same chemical properties. This should be the same. The answer should be same functional group. The functional group is responsible for the chemical characteristics. So the best answer is D. They have different physical properties there because they have different numbers of carbon atoms. For example, like ethane, methane, propane, right? So within a homologous series, they have different physical properties because they have different number of carbon atoms. Right, question 37. Increasing the number of atoms in one molecule of a hydrocarbon increases the amount of energy released when it burns. What is the correct order? The keyword here is increasing the number of atoms in one molecule. So the more atoms it has, the more energy is released. So we have three of them. Methane is CH4. Ethane is C2H6. Ethene is C2H4. So in terms of the number of atoms, it's methane followed by ethene followed by ethane. The answer is D. Right? Question 38. An organic compound P reacts with zinc to produce a gas. What are P and Q? As you can see, this is a metal. What reacts with a metal to produce gas? Which is most likely an acid, and this is hydrogen gas. All right. So which of the following are acids? It should be ethanoic acid, and the answer should be B, hydrogen gas. All right, not carbon dioxide. The only way for carbon dioxide to be formed in IGCSE syllabus is either you burn a carbonate or you try to react carbonate with an acid. And burning fuel. If I'm not mistaken, those are the only three things mentioned in the syllabus. All right? Okay, so these three are the general reactions that form carbon dioxide in IGCSE syllabus. So, question number 39. Alkanes undergo substitution reactions in the presence of UV light. Which equation represents the substitution reaction of ethane? Substitution reaction is carried out using halogens. For example, bromine or chlorine. We're not using hydrogen chloride. And then this reaction is actually pretty stubborn because alkanes are pretty unreactive. So we have to force it by subjecting the alkene molecules with UV light. And even with UV light, it can only be carried out one step at a time, which the substitution occur one atom at a time for the hydrogen atoms. So you can't possibly go from H6 to H4. That's not possible. And the best answer is B. All right, it's one by one. One chlorine atom substitutes one hydrogen atom, and the other chlorine atom, give me a moment. That's the idea. Right, that's the idea. Wait, let me draw it better. Right? Okay. Don't care about this thing first. Just have a general idea. C2H6. One of the hydrogen. Okay. One chlorine substitute this thing. And then this hydrogen goes and form a bond with this chlorine. So the answer is B. Right? Last question. Natural polymers, proteins and carbohydrates, which are found in all living organisms. Right, that's all for this discussion. Thank you for watching, and I'll see you in the next one. Subscribe to my channel if you'd like to see more videos, and I'll see you in the next one. Bye.